Okay, so I'm gonna go through some slides. I'm excited to just talk and dialogue and answer questions and chat about this too. And if you hear barking, it's my pug outside, and if you hear screaming, it's my kid in his bedroom. So I apologize for all of the things that are life related right now. But I just want to briefly, there's some of these slides that you've seen before. If you've seen me present or you saw the presentation earlier, I'm not going to spend a lot of time on them, but I always like to start with them because I think seeing them a million times is not a bad thing. In the poll, it said that 84% of you know what embodied carbon is, so I'm not going to explain it in detail now. But just to frame what I think is the ultimate goal is really understanding carbon in general when it comes to the built environment, and how the work that we do has to be looking at this holistically. The first step is understanding that we do now have these two buckets of carbon emissions that are coming from our buildings. One on the operational side, of course, and of course the embodied carbon's the other half. And I like putting it in images because I think it really starts to remind us, what we're talking about. Operational energy is, of course, all the things that the buildings are doing once they're built, and embodied carbon is really everything up to that point when it comes to how we build our buildings. This is a slide that I think many people use in multiple different graphics, where it's talking about how we know now that embodied carbon is about 50% of the pie from now until 2050. This is data that's supported by Architecture 2030. And we find on average that this is actually true, but it's really important to remember that this is very dependent on where you are. So this is an example of where we took 4 projects with actual square footages in actual places, and looked at them if we assumed an 80 energy use intensity and the grid mix of each of these places. So you can see with each of these projects, they've got a certain breakdown of operational versus embodied. It's very much toward the operational with an EUI that high. If you then reduce the EUI to 40 but leave them in the same place, you can see how that all of a sudden changes, right? So energy efficiency all of a sudden starts to skew the numbers, and of course the tons of carbon go down drastically with our operational energy savings. Then, if you all of a sudden take all 4 of these buildings and put them in Seattle, this is what happens. And this is showing the importance of the energy grid. So when you're looking at a project in Seattle, this is typically about what it comes down to, based on the fact that we have really good code where 40 is about right from an EUI perspective, and an energy grid mix that's largely hydro. So again, just watching these things move, it's really important for us to look at this very specifically on our projects to understand that relative impact. Focus on both, but really start to target, what is that breakdown of operational versus embodied, and how are we addressing that? Of course, as code gets more stringent everywhere and our grids get cleaner, it's going to start to skew this direction. But those tons of carbon that you're seeing here when it goes from an 80 to a 40, then to a clean grid, are very large when it comes to what we're doing on the operational side in terms of savings. So again, 50-50 on average, very dependent on energy grid and how efficient our buildings are on the operational side. So we cannot just look at one or the other, it has to be both. And then just really digging into embodied carbon, because that's where my expertise is these days. This is a good slide by the Carbon Leadership Forum. And I think right now it said that 85% of you knew what embodied carbon is, but 76% of you have not yet completed an embodied carbon assessment on your projects. So this is really the time where we all understand what we're talking about, and we're trying to figure out what to do. So slides like this that are really getting into what we think about when are important. And this is looking at a slide from the Carbon Leadership Forum that's talking about, what to do when. So rules of thumb are really optimize your project. Do you actually need to build the building? Can you retrofit? Can you make the building smaller to meet your goals? So you're reducing materials and program. What are you doing from that program efficiency to really reduce the size of your spaces? Square footage of project equals embodied carbon, really, when it comes to that first impact. The second is really optimizing what you're doing. So now you know what you're building, but what are the systems that are making that building up? What are you thinking about in terms of materials, structural materials, concrete versus timber, envelope A versus envelope B? So that's really the second. And the third, once you know I'm building a building out of concrete and steel, or I have this type of carpet that I need to meet a performance on, then it really gets into the transparency at the supply chain level, where you're looking at, am I picking this concrete over that concrete? Am I picking this carpet over that carpet? How do I start to look at limits for materials specifically and really incentivize low carbon materials through specification and procurement? So all of these are important. It's a circle. If we do the first well, we build less. If we do the second well, we optimize our systems and pick better materials in the first place. If we do the third well, we provide low carbon options for all those materials, which then go back and reduce everything. So it is a circle, and we need to be looking at all 3. This is again the slide I presented earlier, but to look at all three, there has to be ways to do that. In embodied carbon assessment, that starts with whole building life cycle assessment, and there are tools out there that help you do that. I listed 3 that are common here in the States. There are a bunch more, and I'm going to show you a slide in a minute that really looks at that. But it really is looking at those optimization choices, how big is my building? LCA tools are good for that, and that's really what they're best at. Once you've made going into those material assessments, again, you really want to be able to look at what you can specify per material category. That's where the EC3 tool comes in, using environmental product declarations to be able to look at manufacturer versus manufacturer and product versus product. And really, if you do both of those things really well, you can actually realize embodied carbon savings and understand what you did. We need all of this to work well to really reduce as much as we can. And just a little bit of a dig into what this means from what these tools do. So whole building LCA tools are looking at all stages of embodied carbon from product all the way through end of life, and they're using average emissions factors. So this is talking about, you've got a whole bunch of data from a whole bunch of sources around steel. They're going to average that into one number that they use when you're doing your quantification. So it's average data to give you a good lens to look at systems comparisons and things, and is looking at all impacts. So really good at that early stage where you're trying to directionally choose things. EC3 is, again, the next step when it's getting into procurement. EC3 looks at this product stage, and that's because that product stage is typically the largest. I think you saw some slides presented by Tim during our session that looked at how that product stage could be 70 to 80% of the overall impact if you're looking at all the stages versus that A1 to A3. So when it comes to procurement, that A1 to A3 is vitally important and what we can track pretty well right now. And we're using baselines in our tool. So a baseline is a high limit where you can make reductions, again, similar to ASHRAE. So again, I'm giving you all this in context because I think it's good to hear this multiple times. All of these things are brought up in various ways, and we really need to understand the language and the literacy around all of this. But this is really what the ecosystem looks like right now. So I did this for myself because we're trying to figure out how we fit in at Building Transparency and the EC3 tool into the larger ecosystem of embodied carbon. What that's starting to tell me is that we do have all of the tools available. We have multiple choices of how we can approach this. We have multiple methodologies of where to start. And what we really want is all of these bubbles to connect to all of the bubbles. So this is not a bad slide. An ecosystem is what we need to make something thrive. It would be worse if there was 2 bubbles that had everything in them. So this is just kind of a grounding in the fact that we're not at a place now where we need to generate more tools and more data. It's just aligning that data and connecting it well in an ecosystem. And if you pick one tool over here or one approach over there, that's okay. What those of us who are working in this space need to do is really connect what we're doing to each other. So we're not creating, 20 different options of how to do every single thing. So this is a big slide, but still, don't read every bubble. I had to anonymize stuff, and I'm sure there's a million things that I missed. I just couldn't fit any more bubbles on a slide. So what this gets into to me is an analogy that I've been using and thinking about because I have a 9-year-old son who loved this book called Shark versus Train, Who Will Win? And I like to apply this to how we look at embodied carbon. And this is on multiple scales. So we are an ecosystem, but you could all of a sudden think, whole building LCA versus EPDs, who will win? Or tool A versus tool B, who will win? Or baselines versus averages, who will win? And the bottom line is that it really depends on what you're trying to do. Each have their strengths and weaknesses, and each have a role to play. If you're underwater, the shark's going to beat the train. If you're trying to roast a marshmallow, the train's going to beat the shark. So really understanding that it's okay to think about what you're trying to do and use that ecosystem to your advantage to find the right fit for what you're trying to do today. We're never going to have the perfect solution. And to get to that point, shark versus train does this well. None are perfect. There are some things that we're trying to do where the shark or the train is not going to work perfectly, but we still need to do it. And I think that's really grounding ourselves in the fact that if we wait for perfection and one kind of golden answer, we're never going to get anywhere. So use the ecosystem, understand the ecosystem of what we currently have available with embodied carbon, and just start to take action. And the cool part now is that we actually do have resources. So again, the ecosystem slide shows it in this kind of messy web way, which is actually really good. But if we're just looking at where we are now from an embodied and operational standpoint, you just take a snapshot of things, right? We've got tons of resources on the operational side. This is just, again, me pulling certain things that we use for baselines or reporting or resources to understand operational carbon. we now have those for embodied carbon too. So get smart about it. Go to places like the Carbon Leadership Forum, read the World Green Building Council's report on embodied carbon, read the New Carbon Architecture by Bruce King, use the resources that we have to get smart. And I always like to show an example of each of these things. So this is my call out to the Carbon Leadership Forum Embodied Carbon Network. This is a group of folks across the country and in the United States. I think now it's global. I heard there's global chapters now that are coming together to really become the hub for embodied carbon knowledge. It's all volunteer driven. There's over 15 chapters and over 2,000 network participants. So again, we have the resources available to us to really get smart and share data and information. The second is around policy. It's really important to understand that policy drives a lot of this. So if you're looking at policy, of course, we understand operational energy policy and how it works and what it's based on. There's now policy starting to pop up around embodied carbon, starting with Buy Clean, which is very much EPD driven. But there's also thoughts about how you look at carbon use intensity similar to an energy use intensity. So could you do a kilograms of CO2 per square foot to put into building code? And the last one is really, oh, there's an example. So I always forget my shout outs, but of course, this is another example of where a group of folks came together in the Bay Area and put together a low carbon concrete code, piloted it, and now it's actually being implemented. So again, this stuff is happening. It's good to look at how it's working and what they're doing. So go read the code and see if it's something that you could apply to your location. And then tools and certifications. Again, there's overlap where now programs like LEED are looking at embodied carbon through whole building lifecycle assessment credits in the design phase, but also a pilot credit for the construction phase where it's all procurement based. The Living Building Challenge has had embodied carbon in it for a long time. Zero carbon certification looks at it more explicitly. And of course, we have all these tools that are now developing and in place to do both things. So again, I just like to show how now I think we're at a point with embodied carbon where it's again taking action and learning how to do that. And really it's not rocket science what we're trying to do. We're trying to pick the lowest carbon options for our materials. And so what we're finding right now, I'm just going to give an example with this cartoon side of how this is working in things like concrete and steel. What we're finding is that by optimizing our concrete designs during the design phase, which means looking at how thick are our slabs? Can we actually reduce the structure? Can we use lighter, if we make the concrete lighter, that makes the steel members lighter. So there's this kind of optimization that happens in design. When it gets into procurement, it gets into disclosure through environmental product declarations, specifying the need for EPDs, and then for concrete specifically, giving performance mix requirements to a supplier and saying, here's what we need you to meet from a performance perspective. Give us your lowest embodied carbon option with an EPD to verify that. And by doing that on projects here in Seattle and other places in Skanska, we're finding a 30% reduction in the emissions for those mixes just by having the data and asking at no cost. So that's a good concrete example. We're also seeing more disclosure by asking. So people are using request letters for EPDs. We have a first precast supplier in California that's providing environmental product declarations. So really it's ask first if you don't have the data. If you have the data, use it to inform your choices. For steel, it's similar where we have optimization during design, and then during procurement, we're actually looking at, okay, does this steel supplier have plant-specific EPDs? Can we actually go procure their members from this plant over that plant because it's a lower embodied carbon number coming from their environmental product declarations? So again, I think the message I'm trying to convey is just start. Figure out which tool you want to use. It's okay if you don't know if it's the perfect tool. None of them are perfect. It's okay if it's using average data or baseline data. It's still data that you can reduce against. And then on the supply chain side, disclosure, incentivizing manufacturers to disclose and then reduce, and then realizing your savings by knowing what you installed. And just my little plug for EC3, it is a free open access tool. That's what we built it to be. There is no paywall. The data is all available through an API. The database of EPDs is something you can pull from into any other tool. Go register for your free account and just start to dig into the data we have. We are going global, so we are trying to include data from all over the world now and fill that supply chain gap. And that's all I have. So I think that was 15 minutes. I don't really know. But thank you, and email me if you'd like to dig into any of this more. That's what I'm here for right now. Skanska's paying my salary, but I'm pretty much full-time at Building Transparency. So.